good example is generating usernames or passwords. A username requires four uppercase letters and two digits. Each letter has 26 possibilities and each digit has 10 possibilities. Using multiplication principle, we compute 26 times 26 times 26 times 26 times 10 times 10, or 26 to the fourth power x 10 to the second power possible usernames. This ensures millions of unique and secure usernames for system users. Counting in cybersecurity. Cybersecurity also relies heavily on counting. In fact, one of the most critical aspects of security, password strength, depends entirely on counting principles. To measure how secure a password is, experts calculate how many possible combinations exist. The more characters and the character types involved, the more combinations a hacker must try. For example, counting in data management. Data management is another area where counting plays a major role. In databases, we count how many records exist, how many fields are needed, how many queries will be performed, and how many relationships are possible between tables. Counting helps determine whether a database has one-to-one, one-to-many, or many-to-many structure. This allows administrators to organize information efficiently, avoid duplicates, and speed queries. Counting is also used in storage allocation, indexing, query optimization, and database normalization. All of these processes rely on understanding how many combinations or relationships are possible. Counting is also used in encryption, where secure keys are generated from large mathematical combinations. Hashing, which involves counting possible outputs, with force attack prevention, where we estimate how long an attack would take. In short, counting helps us keep our digital information safe. Counting in system design and user experience. When designing an information system or application, developers count the numbers of screens or pages a user will navigate, the number of steps in a procedure, the number of possible user interactions, and the number of test cases required before releasing the software. Each additional choice or step increases the total number of possible user paths. Developers use counting to make sure that the system is efficient, user-friendly, and free of errors. Counting helps ensure that every possible actions the user might take is tested and accounted for. Conclusion. Conclusion. To summarize everything, the fundamentals of counting are deeply embedded in information technology. The ma Aya. Conclusion. To summarize everything, the fundamentals of counting are deeply embedded in information technology. They influence how programmers write code, how engineers design networks, how cybersecurity experts protect data, how systems analysts sign user flows, and how databases store and connect information. Even though counting seems like a simple mathematical skill, it actually supports the entire structure of modern technology. Ano Moses? um, Conclusion. um, Conclu- Conclusion. Conclusion. To summarize everything, the fundamentals of counting are deeply embedded in information technology. They influence how programmers write code, how engineers design networks, how cybersecurity experts protect data, how analysts design user flows, and how databases store and connect information. Even though counting seems like a simple mathematical skill, it actually supports the entire structure of modern technology. Without counting, computers would not function, networks would not operate, and digital systems would not exist. Thus, counting is not just a basic mathematical concept, it is a powerful tool that drives the foundation of information technology. Thank you very much for listening.